Hey, how are we doing there? We're going to start today with 13.1 and just do a couple quick simple trig things. So I'm hoping this is some review for most of you from geometry, sine, cosine, tangent. We will be putting in the other three trig values here as we get going. Make sure your calculator's in degree mode if we start using it. For the most part, we won't be using it that much right now. When we get to the application problems, we will need to be in degree mode. We make the mistake of using our calculator, but all really trig ratios is just opposite over hypotenuse. It's just a fraction, opposite over hypotenuse, or whatever trig value we're looking at. So you're going to need your calculator when we have an angle involved. So sine, cosine, tangent, nothing here that's earth-shattering for you. Trig is just ratios, folks, okay? It's just fractions. Again, you don't need your calculator for working with some angles within those, but it just allows us to find angles given those fractions. All right out of the chute is sine, cosine, tangent. You should be pretty familiar with that. Most likely, your algebra teacher told you that the sine is the opposite over the hypotenuse. Your cosine was adjacent over hypotenuse, and your tangent is the opposite over the adjacent. They probably went with the SOHCAHTOA for you. So I'm hoping that you understand that pretty easily. That's some old stuff. Here's my theta, opposite side, adjacent side, and hypotenuse, okay? Along with that are three other trig values. And they are the cosecant, secant, and cotangent. So notice that they are just the flip of sine. So your sine, your cosecant, and your sine, 1 over your sine, or hypotenuse over opposite. Hypotenuse over opposite. Cosecant is hypotenuse over. Your secant goes along with cosine, and it's going to be hypotenuse over adjacent. And then your cotangent is adjacent over your opposite. So how's that look? So we have the sine of any angle is equal to the opposite over the hypotenuse. The cosine of any angle is equal to the adjacent over the hypotenuse. The tangent is equal to the opposite over the adjacent. So sine, cosine, tangent. Cosecant is equal to hypotenuse over opposite. Secant is equal to hypotenuse over adjacent. And cotangent is equal to adjacent over opposite. And there's your 6 trig values. So we're going to ask you to find those here. Just letting you digest that for a second. All right. We're going to go ahead and do all 6 trig values right now. Move some of this around a little bit. Hopefully that doesn't. There we go. All righty. So the sine of our theta is right here. This would be the opposite over my hypotenuse of 25. The cosine of my theta is adjacent, which would be 24 over 25. My tangent is going to be opposite over adjacent, 7 over 24. Sine, cosine, tangent, cosecant, secant, and cotangent. All we have to do is really just flip those. So it's going to be 25 over 7. It's going to be 25 over 24. And 24 over 7. Sine, cosine, tangent, cosecant, secant, and cotangent. Occasionally, we might make you find the third side using the Pythagorean theorem, so be aware of that. Make sure you realize that if this is my theta, this is my opposite, still hypotenuse, of course, and adjacent. So your opposite and adjacent can change depending on where your angle of reference is. So there's your 6 trig values. Same thing holds true here. This would be your opposite. This would be your adjacent. And of course, hypotenuse. And you can roll through those 6 trig values also. The directions only call for those 3, but you might want to try to practice with the others also. Special rights. There are 2 of them. Euclidean called these the most beautiful shapes he ever saw. The ratios do exist. When you have the special rights, we are going to go for exact answers. I don't want decimals here when we're working with the 30, 60, 90. So decimals will be counted wrong. So make sure you don't have decimals with the special rights. This side is the ratio of 2x. This side is x square roots of 3. And this side is 1x. You're 45. Your legs are both x. And your hypotenuse is x square roots of 2. So the idea is to solve for x, and you can get your other 3 sides. So these are pretty fun, I think, special rights. So the sine and cosine, as you can see there, with those links. Now I put the x in there because those links can change. Once we start doing some of these, we're going to have to solve for that x. And that will be our constant that will go with every side ratio. So this is x square roots of 2. Make sure that is understood. So x down here, x square roots of 2. And these are things you probably need to try to commit somewhat to your memory normally. But obviously, you'll be able to look it up in a book. Let's take a shot at one right now. So we have the 30, 90, and of course, that would make this 60 here. It has to be. So here's how these are all going to work, and I suggest that you go ahead and label. The hypotenuse is 2x, the short leg is x, the long leg is x square roots of 3. So what I'm going to do is take that side that I have, and that is 74, is equal to 2x. I'm going to divide by 2. If I divide 74 by 2, of course, I'll let you think about that one for a second. 74 divided by 2, and of course we get 37. So our x is equal to 37. Now, what does that mean for the rest of that? Well, that means that this side is 74. That means the length of this side is going to be whatever x is, which is 37. And this side is going to be 37 square roots of 3. So we solved for x. Now, that is the hypotenuse is one of the easier sides. The short leg is really easy because that's what x is, and you just plug it in. The hard one will be the long leg. when you have to solve. Remember, we want exact answers here, not decimals. Let's try one of the 45s. Again, we want to label our ratios, and this x is already here, so that's x. This side is x. This side happens to be x square roots of 2. So we're going to take that, x square roots of 2, set it equal to the length of that side. Divide by square root of 2, of course. And we're going to have x is equal to 20 over the square root of 2. Now that is the correct answer, but we do need to rationalize. So we're going to multiply by the square root of 2 over 2. And now we're going to have 20 square roots of 2 over the square root of 4, which is 2. We can simplify 20 and 2 simplify to 10 square roots of 2. So we've solved for x. The hypotenuse is 20, and both legs will be equal to 10 square roots of 2. And that's what we mean by exact answer. We don't want decimals there. We want that exact answer. So special right triangles, we want those exact answers. All right, throw in an application problem now. So, of course, those are always there when we get down here. A water skiing competition, a jump ramp, measures are to be shown. So let's look and see what we got. So here is my theta, my angle, right down here. So across from that, this would be my opposite, wouldn't it? Okay, so that is my opposite side. And it looks like they're giving me the hypotenuse. Looks like they're giving me the hypotenuse there. So I have opposite over hypotenuse. And of course, that is what trig value. Opposite over hypotenuse, of course, is our sine. Sine is equal to my opposite. Sine of the theta is equal to my opposite over my hypotenuse. Well, here's where we want to make sure our calculator's in that degree mode. So our equation is going to look like this. Sine of 15.1 degrees, okay, is equal to the opposite, which I don't have, and we'll just label it as x, over the hypotenuse of 19. So here's where you're going to need to grab your calculator. Make sure you are in degree mode. I'm grabbing mine right now. Got to check my mode. I am in degrees. So I'm going to solve now and see what the height of this is. And how am I going to do that? Well, I'm going to multiply this side by 19 and this side by 19. So in fact, those cancel. So in fact, my calculation is, make sure again, degree mode, sine of 15.1, close your bracket, times 19. And you're going to get, and it does ask us to round to the nearest foot. I'm getting 4.94. So we're going to round this guy to 5 feet. That is when you need to make sure you're using your calculator. Again, these application problems with your trig problems. Yeah, it sounded kind of stupid, but there you go. All right, so that uses a sine. Let's try another one of those. Skateboard, here's our theta. This would be the opposite again here. And we're trying to find the hypotenuse. Okay, so opposite over hypotenuse. Again, sine. So our sine of our theta is equal to our opposite over hypotenuse. Okay, so we are looking at sine of 17 is equal to the opposite, which is 12 over the hypotenuse that we don't know. Now this one's a little trickier because the x is down here. So we're going to multiply by x, both sides, and then we're going to divide by the sine of 17. So really, our answer, our hypotenuse ends up being x equals 12 divided by the sine of 17 degrees. Again, make sure you're in degree mode. And grab my calculator, 12 divided by sine of 17. And I'm getting that ramp at 41. And this is in inches. So this ramp here is 41 inches. Awesome stuff. Hopefully you're doing okay. I think we might have another talk here. Well, we do need to talk about angle of depression, angle of elevation. They're really the same. These would be parallel lines cut by a transversal, so don't get confused. Angle of elevation and angle of depression. Same type of thing for trig questions. So you can set that right triangle up however you want. Let's do one of those, and you'll get an idea what we're talking about. Here is a biologist whose eye level is 6 feet above the ground, measures the angle of elevation to the top of a tree. Da-da-da-da-da. Okay, so let's draw out a diagram here. So we got the right angle. That's my best imitation of a tree. The problem is the guy's standing here, of course. Gotta make him a different color. He is standing, and he is what? Off the ground? 6 feet. Okay? So our angle is 38.7 right here. Okay? And he is standing 180 feet from the base. So that would be this, 180 feet here. And we're trying to find how tall this tree is. And don't forget, we're going to need to add this 6 feet to that. So that would be opposite over adjacent, which is tangent. So the tangent of that angle, 38.7, is equal to the opposite, which in this case we don't have, over the adjacent, which is 180. Is that right? 180? Yep. All right. Again, grab your calculator. We will quickly do this one by doing what? Multiplying by 180 on this side and multiplying by 180 on this side. So your answer is going to be tangent. I'm grabbing my calculator. Degree mode, yes. 38.7, close that, times 180. And I'm getting 144 feet. So 144 feet is how tall this tree is. All righty. Hopefully you're doing okay. And I'm going to move on now. I think we're getting close. You can find the 6 trig values. I'm not going to do that one now. Hopefully, remember, this is where we're going to need to use the Pythagorean. Get your other sides. I can get that to come on now. There we go. Use Pythagorean, get your hypotenuse, and write out your 6 trig values there. I've done this one. I think I have the answers down there so you can practice this. You can look on the PDF. Yes, I do have the answers, so you can check that out after you go through that. So practice a little bit those 6 trig values applications. Again, here's a little 45 too. I think the answers are also underneath there. So we're just going to do a couple problems now. 9 through 33. Excuse me, page 933. 13 through 23 all. So this will be posted Monday morning, and you guys are doing great. Keep up the good work. All right.